So saying the good thing about this chapter is you're not learning any extra math rules from last year. So you're working with fractions. You're looking at how to simplify fractions, which you did last year. We're looking at how to multiply fractions, how to add fractions, and how to divide fractions. That's basically the whole extent of this chapter, which is exactly what you did last year. The only thing that's changing is the difficulty level of the questions. So all those same rules apply from last year. So we're just going over the rules and just giving you a harder level question, applying those rules. Okay? So let's begin with a quick recap of last day. So a fraction represents parts of a whole, right? So on the diagram on the right hand side there, we have 8 boxes altogether, and we can say 4 of them are shaded, right? So that would be a fraction because 4 out of the 8, 4 parts out of the total are shaded. Now, with fractions, the same number can be represented in multiple ways. That's why we need to sometimes reduce to lowest terms or find common denominators. That's this same diagram, you could also say half of the boxes are shaded, right? Because so you can say 1 out of 2 boxes are shaded. Now, as a decimal is 0.5. So yesterday we started techniques of how do we convert decimals to fractions, how do we convert fractions so that they all look not look the same, but they have the same denominator so we can compare them. And that's what we're going to continue on with. So just to warm up there, it says compare the fraction 3 over 8 and 2 over 6. Okay? So when it says the word compare, how do we compare? When you're talking about fractions, we're going to say what's bigger, what's smaller. Conveer?
You have to find the lowest common denominator.
Yeah, lowest common denominator. And this, we look at the denominators, we have 8 and 6. And what would that be in this particular case? What number can both these multiply into? David?
2.
No. You can't change the denominator to 2.
No, like you can multiply.
Multiply by 2?
You
So
can go to 16.
you can go 16. So 8 can go to 16, but 6 cannot. 6 times something, you can't get a multiply by a whole number. Kabir?
24.
24. So that's the smallest number they can both multiply into. Right? So this one on the left is we multiply by 3, the top and the bottom. So we ended up with 9 over 24. And 6 times 4 was 24. And 2 times 4 is 8. So now we have the fractions with a common denominator, so we can compare them. When comparing, we can say which one's bigger or smaller. So which one's bigger here? The one on the left or the one on the right? The left. So to compare, just compare the numerators. The denominators are the same. So the mouth opens up to the one on the left. 9 is bigger than the 8. Right? So now we can say, using the original fractions, we can say 3 over 8 is bigger than 2 over 6. Okay? Let's just do this A example, then we'll skip to starting today's notes. Okay? Looking at this diagram, can you write me a fraction that represents this diagram? Kabir?
3 over 12.
Okay. So what does the 3 represent and what does the 12 represent?
3 is the shaded, 12 is the whole.
Yeah, so there's 12 parts to this and 3 parts are shaded. Now, Kabir could also said that there were 9 white parts and over 12. So that's another fraction you could write with the exact same diagram, right? Okay, but the question actually asks for a shaded part. right? Now, the next part is I'm going to ask you is to simplify this fraction. So can it be simplified? And if so, what to what, Jacob?
It can be simplified to 1/4.
And how did you accomplish that?
So you can divide both numbers by 3.
Divide both numbers by 3, which equals 3 divided by 3 on the top is 1, 12 divided by 3 is 4, so 1/4. And finally, can you tell me what 1/4 is as a decimal? Kabir?
0.25.
0.25. Now you can use that in your calculator, but 1/4 is one of those common fractions that you'll see a lot. It's a quarter, right? So you should get a habit of knowing what the decimal is. So 1/4 is a quarter. Another common one is a third. So 1/3, which is 0.33. Another common one is a half. 1/2, which is 0.5. And 3/4, 0.75. You'll get used to seeing more and more of them. So let's just, I think you guys got this, so we don't need to do any more review. Let's get into today's topic. All right, so we'll be looking at, start off with rational numbers on a number line. So we're given 4 fractions here, right? And we want to say which one of these letters represents each fraction without using our calculator. All right? So we're going to use a strategy to help narrow our choices down. Right? So they're saying that these numbers do represent these fractions. So we start off with that. Then we go, okay, how can we justify what each fraction is? Okay? And what I suggest is starting off with the extremes. So you have 4 fractions there. Which one of those fractions would you say is the biggest one? So you have 4/5, 1/2, -5/4, -4/5. Which one's the biggest? Braden?
4/5.
4/5. Okay, it's positive, right? So it automatically makes it bigger than any of the negative ones, right? And then, and I would agree. So 4/5 is the biggest. So that's going to be the one that shows up furthest to the right. So if we had to place it on the number line, given these choices, D would probably be our best guess, right? Did you do questions like this last year? All right? No? So if we had to place 4/5, I'd place it at D without even doing any calculation, without even knowing what 4/5 was. Okay, what would be the smallest? Which one would be the farthest to the left? The biggest negative number? David?
-5/4.
-5/4. So you're choosing -5/4 versus -4/5. And why did you choose that one?
Because in negatives, the bigger the number, the smaller it is.
Yeah, the bigger the number, the smaller it is. So now -5/4, since the top number is bigger than the bottom number, this number is bigger than 1. The other one is going to be, this one's going to be a decimal, right? Because the numerator is smaller than the denominator. And this one's bigger, so this one's going to be further to the left. So I do agree. So looking at this, the one that's furthest to the left is, oh, wrong spot, C. So that fraction would represent C on the number line. Okay. Now we have 2 spots to choose from. Can somebody tell me a strategy they're going to use to figure out what letter represents 1/2 or one letter represents -4/5? Kabir? Not Kabir. Conveer?
I chose A for 1/2 because A is to the left of, I'm sorry, to the right of 0.
Yeah. A is positive, so it's going to be to the right of the 0. Fair enough. Right? And that means this one has to be B. And it fits in. Okay. So next question is, which letter is closest to 0? Now you can't always tell that from a fraction, but a number line that makes it a little bit easier to see. Which one's closest to 0? Sorry, 8? Yeah. Right? This is the closest distance right there versus all the other spots. Okay, which fraction is closest to the 0? That means, Isaiah? 1 over 2. Okay, which fraction is the smallest? Okay, Karnveer?
Negative 5 over 4.
Negative 5 over 4 means which one's the furthest to the left? That's what this question is saying. Okay? Now, for D, I don't think we need to write anything down. David did a pretty good job of explaining his reasoning when he did it, right? He said that the one with the bigger number is further away, and hence negative 5 over 4 is further away, or the inverse of that, negative 4/5 would be closer to 0. So David did a good job of talking about that. Okay. Now, take a moment, and I want you to do B, question B here by yourself. Right? Go through our process of elimination. Which one's furthest to the left? Which one's furthest to the right? Then sort of make some judgment calls. And at the end of the day, you may not be able to get all of them, but we can talk about those. Give yourself a starting point, right? And we'll discuss what you come up with. You can use your calculator, but I suggest trying to do this without a calculator altogether. And looking around, I think most people are either stuck or done. Right, so let's give this a try. Okay. Can somebody help me out and say what was the first letter that they were able to place to a fraction? Braden? F, and what did you call F? Which fraction?
The 7 over 4.
So Braden said 7 over 4 was F. Do people agree or disagree? Kabir?
7 over 4 should be D.
So we got somebody disagreeing. Okay. Isaiah?
I also disagree,
You,
but I think F is 2 and then 1 over 5.
now I would agree with Isaiah. Now how do we come up with determining which one's the correct one? Right? So we have F is to the right of the number 2. So our fraction has to be bigger than 2. Right? So we have a 2 here plus a 5th. So that's going to be to the right of 2. So that's the thought pattern I would have gone through for determining what F is. Now 7 over 4, right? I can tell that's less than 2. How do I determine that's less than 2? Well, I know 8 over 4, like 8 is double 2, that'd be at 2. Right? So since 7 is less than 8, I know that that point is going to be less than 2. Okay? That's the strategy I would have used. So we can say 7 over 4 is D. Did somebody else want to place another fraction for me? Jacob?
B, which is negative 2.1.
B, which is negative 2.1. So you're saying that one is the furthest to the left. That looks like the biggest negative number to me, right? Compared to all the other negative numbers I see, that looks the biggest one. Now we get to the hard part. We have EAC, which are really close together. So anybody want to discuss a strategy they use to separate these out? David?
I think negative 0.49 is E because it's towards the middle.
Okay.
Negative 1, so I think,
0.49, yeah, it's very close to 50.
yeah.
All right. But, so I agree, should be somewhere in the middle. And compared to the other ones, so you just can't go off that one. You have to compare it to the other information you got there and see if it confirms with your other thoughts. So you have this fraction here and this fraction. So using your rationale, is 0.49 more closer to the middle than negative 0.3 and negative 1/3? Right? Yeah, and I would agree, right? So always double check your thought that you came up with the other information that's given. So okay, E. Now we're left with two more to go. Isaiah?
Well, I know that 1 over 3 is 0.33, and
Yeah.
it's a negative, and 0.33 is bigger than 0.3, but it's also on the negative side, so it would be farther to the left. So I think negative 1 over 3 is A, and negative 0.3 is
Yeah.
C.
So excellent. So Isaiah was saying that this is negative 0.33, right? So you're comparing decimals. That's a common fraction. That's a bigger negative number. So that's going to be furthest to the left is what he said. So that would be A. That means this would be C. Excellent. Right? And that's the strategies I want you to use. Now, you're going to get to tests, and it'll be like, hey, this test has 2 parts. One part is you can't use a calculator. The second part, you can use a calculator. So all calculators go away. Once you've done the calculator portion, you can do the, once you've done the non-calculator portion, you can pull out your calculator to do the calculator portion. So those kind of tests are how teachers and the ministry get you to do this without having to use a calculator, but only using your mind to rationalize it. So don't think you can just get away with, like, I can just find the decimals and figure this out. We actually need to be able to come up with a strategy. Okay. Okay. So in the next question is, we've got 2 numbers, okay, or rational numbers, and we want to find what is the number, the fraction that exists in between these 2 numbers. So if we were to plot these numbers on a number line, and we'd have, let's grab a pen here, and we had 3/4 here and 4/5 here, what fraction would be here? Okay. I've helped so many students with this, and it's like people sometimes get lost and don't know what to do. But once you figure out the strategy, these questions become quite easy. So what we need to do is, when we're comparing stuff, is we want to have a common denominator so we can compare. And it also helps us figure out what might be in between those, because now we know how to rank these. So in order to do this, we need a common denominator. All right. So we have 3/4 and 4/5. What would be the common denominator here? Braden? 20. Okay. So the one on the left, we're going to multiply. 4 times 5 is 20. So we have to multiply the top and bottom by 5. So 3 times 5 is 15. And for the one on the right, 4 times 5 is 20, and multiply the top and bottom by 4, so 16. Okay. So our number that is in between this has to be between 15 and 16. So that'd be like 15.5, right? So, but we can't have a decimal in a fraction, right? That doesn't make any sense. So what we need to do is make a bigger equivalent fraction, because we can't get a number between 15 and 16. They're too close, right? So we make a bigger equivalent fraction by saying, hey, let's take this, instead of having 20 as our denominator, let's make 40 as our denominator. So let's multiply the top and bottom by 2. So we can go 15 times 2 is 30, and 20 times 2 is 40. And we do the same thing to the other side. Multiply by 2, multiply by 2. So we have 16 times 2 is 32, 20 times 2 is 40. Oh, 40. Okay. So now, can we tell what number would be in between those two? David? No, not David. Yeah, David. Yeah. Sorry.
31 over.
31 over 40. So the number in between here, let's go green, would be 31 over 40. Okay. And most of the time, you know, when you did the first step there, the common denominator, that'd be enough to tell you what's in between. But if not, then just increase it by a multiple of 2. Now, if that doesn't work, increase it by a multiple of 3. All right? And then eventually it'll give you a big enough gap that you can figure it out. Let's do this one more time. Okay? It says, find the fraction that's in between these two decimals, right? So they're decimals, right? Let's convert into fractions because we want to find a fraction in between them. Yes, David?
0.4 would be 4 over 10.
All right, so we discussed that yesterday. You take the number to the right of the decimal, put that on the top, and the bottom we put a 1, and how many digits we see is how many zeros we add, so that's 4 over 10, and we just got to make sure we include the negative as well, right? So David, what would the negative 0.5 be as a decimal?
Negative.
Sorry, as a fraction, yeah.
Negative 5.
Negative 5 over 10. So the number in between here would be 4.5, but we can't have a 4.5 in a fraction. So let's do the same trick we did last time. Let's increase our denominator so we can add more space on our number line. So let's multiply this by 2, and this one by 2. So we end up with negative 8 over 20 and negative 10 over 20. So what's the number in between? Karnveer?
Negative 9 over 20.
Negative 9 over 20. So the number in between here is negative 9 over 20. Okay. So not always is going to fractions necessarily the easiest approach. So let's look at the next question. Okay, so find as many integers between these two fractions, negative 7 over 2 and 11 over 3. So in order to answer this question is we need to know what an integer is first. What is an integer? David?
It's the numbers on their number line.
The numbers on the number line, right? The whole numbers, like including positive and negative. So negative 5, 4, 3, 2, 1, 0, all those kind of numbers. Okay. So we want to know what are the numbers in between these two. So let's just figure out what numbers do these fractions represent. So can you give me what the decimal value of these fractions are? What are the decimal values of these fractions? What is negative 7 over 2? Grab your calculator. Give me the decimal value. Okay. I'm gonna go for Cronenbeer for the left one.
Negative 7 divided by 2 is negative 3.5.
Negative 3.5. And David?
It is
11.
2.2.
22, did you say?
No, 2.2.
2.2.
2.2.
Okay.
No, okay, I did 11 over 5.
So, okay, 11 over 3,
It's 3.6.
3.6.
Yeah.
Okay, so we have our number line. We have negative 3.5 somewhere over here. We have 3.6 somewhere over here. What are all the integers in between here? So you start from one end, you start working your way through. What are the integers? Okay, David.
Negative 3.4, negative 3.
No? A decimal is not an integer. So you're talking about the whole numbers counting. Isaiah.
Did I say all of them or?
Just start from the left side and work your way across.
Okay, so negative 3, negative 2, negative 1, 0, 1, 2, and 3.
So those are all the integers in between. Right? Not the decimals. Right? But the whole numbers. Right? I'm using whole numbers incorrectly because that's supposed to be positive numbers, but integers is positive and negative numbers. Okay? Right? So some of it just getting used to the terminology, right? Okay. And I think the next one is the last question for this morning here. All right. So for E, it says compare and order the following rational numbers. So these numbers here. Order them on the number line here. And so we can either convert everything to fractions or convert everything to decimals in order to accomplish this. Right? So it's giving you a choice. What method would you like to do? Would you like to convert the fractions to decimals or the decimals to fractions? Which way would you like to go? Right? So pick a method. Someone. What do you think of Biman? What do you think of it?
Fractions to decimals?
Fractions to decimals. I agree. Right? Decimals are typically easier to work with, right? And if it gives you a choice, go for the decimals. Yeah, we can convert the fractions, so the decimals to fractions. We know how to do that. But then after you do that, you have to make them all have a common denominator. So there's a couple of steps involved there. Whereas converting a fraction to a decimal is we just pull out our calculator and divide the numbers and we get the number. So can somebody tell me what 5 divided by 8 on the calculator is? What is that?
0.625.
0.625. Negative 9 over 10, what would that be?
Negative
0.9.
Excellent. Negative 0.9. And that would be just positive 0.9. Okay. So we got them all as decimals. Can you please place them on that number line? So where it says B here, place all these numbers approximately where they belong. Does anybody want to help me get started here? Okay, David, before I get you to say where the numbers are, can you tell me did you figure out the spacing here, what each line represents? How much space does each one of these lines represent?
I think it's 0.1 every single thing.
Right? Because before you can start placing the dots, you got to know what each one of these lines represent. So David thinks it's 0.1,
It's 0.2.
0.2. Yeah, I would agree. There's 5 lines, so if you go 0.2, 0.4, 0.6, 0.8, that would be 1. So that will help you determine where to put some of these numbers. So each line represents 0.2, and it's 1.2, 1.4, and so on. Okay. David.
I wrote 8 under negative 2.1, stop 2.2.
Okay.
That would be line right after negative 2.2.
Okay. Right after,
To the left.
right? Because they're going up by 0.2, so we can put an A there. Okay. Excellent. Next one. Anyone? You don't have to go in order. Does anybody definitely know where one of these lines go? Bimin?
For 0.6, I put as B.
0.6 as B.
Yeah.
This one here. Okay.
And it's 2 lines from positive 1 to the left.
1, 2. And Bimin says right here. People agree or disagree with that placement? Jacob?
I think it should be just slightly over to the right since
Yeah.
the answer would be 0.63.
Yeah, so we're trying to get not exact, but we want an approximate. So that line is 0.6. Our number is 0.625. So we don't have to go right on the line, but it should be just to the right of it. That would be a better placement of B. Just slightly to the right of the line. Right? Okay, does anybody have another placement? Hunter.
For negative 0.9,
Yeah,
that's C.
okay.
When you go down the number line to negative 1, it would be
Yep.
it would be in between 0.1 and the 1 line.
Before that, okay. I get it. I get what you're saying. So C would go right there. Right?
Yeah.
Okay. David.
Negative 3 would be in the middle of negative 2 and negative 4. The line.
The negative 2 and negative 4, or you mean negative 0.2 and negative 0.4?
Negative 0.2, yeah.
Okay, so negative 0.2 is right here,
Yeah.
negative 0.4 is right there, so
the
somewhere in the middle, right? We're not going for, we'll call that D, we're not going for exact, but we're going for a good estimate. All right? And the final one, Jacob.
The E would be halfway between the 0.8 and 1 line.
Yeah, there we go, right in there. And that'll be E, we place it there. Right? So now, we got these numbers on the number line. Arrange them from in ascending order. So what does ascending mean? Increasing. All right? So A is our lowest, so it's negative 2.2, then followed by C, which was negative 9 over 10, then followed by D, which is 0.3. What does the line over the 3 there mean? Kabir?
The 3's go on.
The 3's keep on going on. It's repeating. That's what the line above the 3 means. Okay. Then we had D, which was, oops, C was 0.9. Did I make a mistake? A, C, D. Oh, they're right. Then it's B, which is 5 over 8. Then it's finally E, which is 9 over 10. Okay. So that's it for this lesson. Let's take a 10-minute break. Then I'll give you, not questions out of the textbook, but I'll give you a worksheet for this set of homework.